Good morning, dear students. Welcome to this class on pre-stressed concrete. We are now discussing Unit 2 of your syllabus, and in which pre-tensioning systems we have talked in the last session. Let us just recall what was discussed in the last session. So we talked about pre-tensioning systems where the essential things required for pre-stressing. So this diagram depicts what is required for pre-tensioning. Pre-tensioning needs abutments. Pre-tensioning needs a pre-stressing bed, and it needs a jock, and it needs a mold for preparing the concrete. Okay, so this all now the required things for pre-tensioning. Okay, so once the tendon is pulled using the jock, and at one end you have anchoring the tendon, the other end you are pulling the tendon by the jock. Once the tensioning operation is done, then you are going to prepare the concrete. Once the concrete is hardened, then you are going to cut this tendon. That completes the pre-tensioning operation. The member is ready for use. Okay, so the stress that you have created in the steel is transferred to the concrete. That is what we call pre-stress. And this process of doing the inducing pre-stress in concrete is called pre-tensioning. Pre-tensioning means tensioning the tendon prior to the preparation of the concrete. Okay, right. So that's just to recall what happened in the last session. And we have talked about the advantages of pre-tensioning and disadvantages of pre-tensioning, and also the devices, essential devices required for pre-tensioning. Okay, and now coming to the other type of system, which is just an extension of the pre-tensioning among the pre-tensioning systems, is like Hoyer system. Okay, it is just similar to the pre-tensioning system, uh, but this one is used for mass production. If you want number of such members to be prepared like this, just for example, it is shown just with this three molds. You can have a very lengthy bed, pre-stressing bed, a lengthy bed which can accommodate 100 of such members, tens and hundreds of such members, and even in the parallel lines also. So that we call it as Hoyer system, or the long line method. Okay, either Hoyer system or even Hoyer's long line method. Okay, is also the name for this technique, and it is a pre-tensioning technique. It is a pre-tensioning technique. Instead of making one member at a time, we can make hundreds of such members. Okay, so that is what is Hoyer system, or else long line method. Okay, so this is the schematic representation of Hoyer system. This is the representation. Just instead of one mold, you just draw two or three molds in a series. Okay, so that is what is Hoyer's method. Nothing more than that. Okay, right. So the end abutments have to be sufficiently stiff and have good foundations. So the problem with the pre-tensioning, we have already talked about this. Like this foundations, like abutments, these abutments shall be very strong, okay, so that they should not move. These abutments shall be stationary, they should be in place while you pull the tendon with a heavy force, like the 2000 megapascal. If you are inducing, you imagine how much force you are pulling it with. So for that force, these abutments have to be in place. That is the task in pretension. Okay, so this is usually expensive to make such abutments, end abutments, particularly when there is a large pre-stressing force required. Okay, so to make an abutment which is very strong and stiff, okay, so that is very expensive, right? This can be avoided, the necessity of stiff and strong abutment can be bypassed by a solution, okay, which can be cheaper also. What is that? Okay, it is like a system called self equilibrating system, famously known as tension frame. Okay, so this is what is the replacement for end abutments. Instead of having end abutments, you can have a tension frame, okay, which is cheaper and no, which is effective, right? So what is that? It is shown in the figure. What is tension frame? Okay. So the jog and the specimen tend to push the end members. I'll show you in the diagram, and I'll explain you the operation of that tension frame. So replacement for end abutment is tension frame. Okay. Need, what is a need? Because the end abutments are very costly, and in fact it is very difficult to make them stiff and strong, particularly when large forces are required. So hence we need to have a simpler solution and an effective solution. That is what is called tension frame. Okay, right? So now what is tension frame, we'll see in the picture. But the end members are kept in place by members under tension, such as high strength steel rods. So what does a tension frame consist of? So it will have end members, it will have a jock, it will have steel rods. Okay, that I'll show you in this diagram. So this is a typical diagram for tension frame. Okay, so instead of abutment, we'll have this simple frame arrangement. So you have a top member, have a bottom bar, top bar, and you have, see, high strength steel rods. These are high strength steel rods. Okay, and this is the member that you want to push. Okay, this is a hydraulic jock. So when the hydraulic jock is operated, it will try to push the specimen. Okay, when a hydraulic jock is operated, it will try to push the member. So whereas the member is supported by a frame, so it will not move, and in turn it will push back the hydraulic jock. Okay, so this is what is the operation here. So that hydraulic jock is again attached to a frame. So this frame and this frame will try move away. Then who will hold them? The high strength steel rods. They will try to hold these frames together. So this is what is the tension frame technique. Okay. So these are the free body diagram of the different parts of it. So this is what I call the pre-stressing force applied. Okay, whereas the reaction in steel rods. Okay, so this is force applied onto these frames. In turn, they will apply the force on steel rods. So you don't have to worry about any strong foundation to be made for an abutment. There is no abutment required. Just the frame is sufficient to put it, arrange this frame at the end of the member and try apply the jock. That will take care of the entire tensioning operation. Okay, so this is how this will go now, right? So the frame that is generally adopted in pre-tensioning system is called stress bench. Okay, the tension frame, the name is particular to pre-tensioning system, is named as stress bench. Okay, the concrete mold is placed within the frame. Okay, and the tendons are stretched and anchored on the booms of the frame. Okay, so this is a frame, this is another frame, right? Another end of the one, that frame. It was just extended, whatever is shown in the last diagram. Okay, so this is how it is. There are eye sections, you can see eye sections. These are the steel tendons, and there are three such members, which is a long line method, Hoyer system. So not just one specimen. There are three such concrete specimens. Okay, and so these tendons are being pulled by the hydraulic jock. Okay, this is a hydraulic jock which is operated, which is trying to move this frame away. So this frame, along with that frame, it will pull these three tendons away, and they are anchored at the other end. You can see they are anchored at the other end. They are being, pulled by the frame, which is operated by, which is pushed by the jock. Okay, so you don't see any, no strong foundation here. It's just a tension frame, extended form of tension frame, whatever we call it as stress bench. Okay, so that is what is the operation that we see here. So this, you can see the strands here, mold, and which is in plan. The same is shown in plan. This is in elevation. Okay, so this is what is the replacement for end abutments. Okay, right. The free body diagrams are also being plotted for the same sketch which is shown earlier. So this is one such frame, and you can see that the tendons are being anchored here, and they are being cut at this point after the mold is prepared. This is the location of cut. Okay, so once that is cut, and even at the intermediate locations also need to cut the tendon so that all three members will be ready. Okay, and these are the hydraulic jock operations. Force is being applied by the jock. This is a frame, end frame. This is another end frame, kept it here, and these hydraulic jocks will try to pull the tendon against this frame, so that pulling operation is shown here. Okay, so this is how the figure shows the stress bench, how it works. So after casting of the concrete, how it looks like, these diagrams are shown. It was only the molds that we have seen. Now the concrete members. There are three such members, concrete molds placed and poured the concrete. Once the concrete is set, we are going to cut the tendons at these locations and also between the members, so that they will be ready. Okay, right. So in particular, today's session, we have talked about two things. One is a Hoyer's system, which is nothing but a pre-tensioning system only. Okay, what is the pre-tensioning system available for bulk preparation of uh, pre-tensioning, bulk preparation of members in pre-tensioning? If you ask me, I'll answer it is a Hoyer's long line method, Hoyer's method or long line method, Hoyer's long line system. It has such names. Okay. So, and the other thing is we have talked about replacement of the end abutments, which are very need to be very strong and stiff. They are costly effort, so they need to be replaced, and that replacement is by a tension frame, a general name, and its operation. That tension frame is adapted to the pre-tensioning operation by naming it as stress bench, by just keeping apart these uh, end frames. We keep apart and we make this, which was a test specimen shown earlier. Now it will be a long line system having number of molds placed in this in the place of test specimen. Okay, and entire operation is very similar. Okay, so this is what is the today's content. So you have to practice all these diagrams to draw at least in line diagram nature, so that you can better present the whenever you are asked for explain the pre-tensioning system. And when you are asked for explaining pre-tensioning system, it is enough if you just produce abutments with one such mold. Okay, and if you are asked for explain about Hoyer's system, you need to produce at least 3 or 4 molds to be kept in between the abutments. Okay, and now the cheaper option for abutments is the tension frame, which is self-equilibrating system. Self-equilibrating system. Okay, forces equilibrate within themselves within the frame. You don't need any external support to equilibrate that force. Say for example, if you are applying a force externally, and this has to be provided with a strong support, otherwise this will move away, right? So if you have a system where this force is taken care of internally, you don't need any external support at all. That is what is this tension frame. This is generally we talk about the applications of tension frames are very much in research oriented, right? Okay, right. So practice these line diagrams in the form of line diagrams at least, so that you can produce them in a much better way, right? Okay, right. Thank you. We'll talk about jocks, hydraulic jocks, anchoring devices, harping devices, and we'll see one example of pre-tensioning operations in a large scale happening. So manufacturing of railway sleepers we'll talk about in the next sessions, right? Thank you.